folks on the air calling CQ 20 meters.
Joe Avampado, and the subject tonight is the Maidenhead grid system. And a little bit about myself. I'm a PE, retired. I did my service time with NOAA as a NOAA officer that fulfilled my military obligation. I'm a life senior IEEE, and my present call is W8DKR. I spent 20 years in industry and 24 years in various teaching at colleges and universities, and I retired from York Tech. And Dr. Tarpley was my supervisor at York Tech. And when you do a YouTube video, you should be conscious of who your audience is. And it turns out on ham radio operators, the two types of people, I think. The old-timers like me, and there's people who just recently got their license. They be young or old. So if you look at what are their needs, of an old-timey ham radio operator, I believe, in my personal opinion, that look at this purple area down here. That's where you need to have YouTube videos on operation of their rigs. They're really complicated. And it turns out that the manufacturer of these radios have really good, professionally done YouTube videos of how to operate the radios. Not like the old days, you just turn it on. It's not that way at all, especially SDR radios. So that area, we probably can't do too much. But if you look in this upper area over here, where you have transmission lines, antennas, and propagation, there is complicated because it's changing, and the theory sometimes doesn't agree with what your practice is. That's because there's so many other unknown factors. So I think I could do something in there, especially with the Smith's chart and transmission lines. Now, you go to the new ham radio operators, and they may be new, young, or old. Not just because they're new doesn't mean they're young. And we have some old-timers in there as well, just got their license. And what are they interested in? Well, they want to advance from a technician to a general to extra class. So they want information on how to pass the test. So the YouTube presentation should be a little bit on that. And I did something like this 8 years ago for extra class license. I worked out all the math. So if you look at this area here on your test questions, they're analog and digital. So the analog is the old stuff, and there's always going to be plenty of that. But also what comes on is some new digital theory like flip-flops, NAND gates, Boolean algebra, and that is coming to more and more practice because as the world goes to digital, that becomes more important. So I could do both. And so if they want me back, I could do both. But tonight's presentation, though, it's going to fall in the miscellaneous. It's not really too technical at all. So that's where we stand. Now, where is the Maidenhead grid used? This may be a little confusing to you, but I want to show you these numbers and letters right here are the Maidenhead grids. JO51, EM94, and NO14. Now, the interpretation here, like Germany, USA, and Asiatic Russia, that's another program doing that. And this information over here, it belongs in another lecture. It's really FT8. So I'm only going to concentrate. These are the locators where the amateur radio operator is located. For example, Germany is too broad. It's a big country, where JO51 narrows it down a little bit better. So, given a little history, from 1956, that's when I got my license as a 16-year-old, and it was in Pennsylvania. And later on, when I moved to Ohio, I had to change my call to a call, because that was the rules at that time. A call, you're in Ohio, that's 8 call. So the ARL is divided the whole country into 10 areas, from 0 to 9. So if you worked a station in, say, in the 9 area, you knew he was from either Wisconsin, Illinois, or Indiana. You knew that. And 6 out here is California. If you worked with somebody in California, it was the 6. Notice California had their own state because there's so many amateur radio operators out there because of all the technology that they're number 6. So after college, I came down to South Carolina. I served my time in NOAA, my military obligation in NOAA. Then I came down to South Carolina. And when I came down to South Carolina, things were all different. It used to be the rule was east of the Mississippi, the call letters begin with W, and west of the Mississippi, they begin with K. But my call was a 1x3. That means a 1 letter followed by a number, followed by 3 other letters, W8DKR. But I came down here, and as time went on, strange things were happening on the calls. In fact, I'm a casual operator in ham radio. I'm not one of these guys operating every day, maybe a couple hours a month, or not even that. But when I started listening, I said, wow, what happened here? The calls, some of the calls started with N, started with A, and I thought, what's going on? This doesn't make sense. So you no longer can tell where the operator is from by only his call. Now, I know about QRZ, where you can look up and get the location about that, but we're thinking of tying a call along with the call letters, tying a location with a call. So something had to be done. So there was a town in Maidenhead, England. It's a funny name, right? But that's the name of the town. And the VHF managers got together in 1980, and they said, well, let's do something about this. We have the present system on like north-south latitude, east-west longitude. You need that information. If you're aboard ship and you're using the stars that navigate, you need to know, boy, you need to know what latitude you're in. If you don't, you're in big trouble. But the east-west longitude and north-south latitude, so that's what's used a lot. But we need something simpler than that. That's a little too complicated. And so what has happened is they looked at it and said, well, how can we make something simple? And, when we talk about radio hams, kind of make it simple. So what they did, they got a map, a map of the globe, and they split it in 324 areas, a 10 by 10 degrees of latitude by 20 degrees of longitude. And you'll soon see why. And what I did to make the arithmetic easy, I convert everything to seconds of latitude and seconds of longitude, just by get the degrees and multiply by 60 and multiply again by 60. Okay, so here it is. This is where I start. The Mercator projection. This is what you see hanging in the schools of the United States. And you see that immediately notice one thing, that Antarctica is really, that's distorted. And up in the northern part of Greenland is distorted. But by and large, where most of the people live, it's fairly accurate, okay? So what they did, they started always at the bottom left-hand corner. And so an A all the way up to R, stopped at R. And then it started at the bottom left-hand corner here, and went from A to R. And that's total 18, by the way, 18 areas from A to R and from A to R. And that's why I picked, so there's no Z, for example. And they use capital letters, A through R. And when you read it, it's always column first and then the row, column and row. So that's the start. And just to give you a preview of coming attractions, this is way too big. Up here, this EM is way too big of an area, so we're going to slowly break it down into smaller bits. Okay, so I'm going to use my QTH as it's EM95MA73TM. Nobody does this, but I just would use it tonight to show you, give the feel for what's going on. Normally a 6-place grid locator is sufficient, but I added 4 more. And this is the rule right here. And I'll go over it in a minute. But first of all, let me say is, if you have any children or grandchildren, see if they could do this themselves, because it's not that complicated. You need a map, a Mercator projection, you get it out of a book, And you could, if you had a little bit of knowledge of Excel, you could do the grids, and I'll show you later on how that works. But basically, this is the rule, and it's really easy. Start out with the capital letters. Remember, this range here is AA to RR. That's 324 areas. After you're done, then you go to a number system. The number goes 00 to 99. Now, what I'm showing you is these are my QTH, so but these numbers here could be 00 to 99, and that's 100 locations. And I might make a remark here that in computer people, when they start counting to 10, for example, they say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the average Joe on the street will go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the problem there is when you get to 10, you've got two places to worry about. And 0 is a number, and 0 is also a memory location. And computer people know that. So, okay, they're very consistent. So after you're done with the numbers, you go to the letters. And here they go from AA to RR. They picked that number so things would fit. So there's no YZ there. And they divide the 24, the vertical and horizontal, by 24, and 24 times 24 is 576 areas. So what they did, they used this grid system on top of this to find your location. Again, I have maps to show you, and you could follow me. And after that, they went to the numbers again, and numbers go 0099, which are 100 different areas. And after that, they went back to lowercase alpha characters with 576. So this is the master. This is the master right here. It's all you need to know. So you don't have to memorize it. You can just copy the slide. So, and now, I use internet programs listed at the end of this program, and graphical methods. But concentrate on graphical methods, especially for the kids. If you use a computer program, you lose what's going on. You type a number in, you get a number out, you don't know what's going on internally. So graphical methods can immediately see what's going on. So there's our EM area we're interested in, but here's give you more details. Here's EM, and it's 36,000 seconds of latitude and 72,000 seconds of longitude. And so we have their EM. Now, what we're going to do with that EM, we're going to divide 10 with the vertical and 10 with the horizontal. I'll give you 100 areas. And we'll do this. Now, this is a little bit clearer now. This is where you could overlay in the map, see? So this is the EM right here, in the red. And over here are the numbers. See, 00 all the way up to 90. Over here is 00 to 1. Yeah, to 00 to 09, sorry. And but the thing is, this corner is 00, and all the way up here is 99. It's the highest you could go. So in my case, I know I can look through it because it's transparent. I can see the land there. Oh, that's about where I live. So it happens to be there. And if I go over here and look at that square, it's 90, 91, 92, 93, 94, 95. So that's how I got that EM95. So you could see what's happening here is I'm going from this large area into this smaller one. Now I'm going to take this smaller one and go down further. So it's, as I say, it's not that difficult. And this slide shows you that because the world is not, the Earth is not a sphere, it's a little different. And so because it's rotating and all that, you got the moon and things like that. So if you want to figure out how many, at 35 degrees latitude, 1 mile is different than other places. And right here is, so at 35 degrees latitude, 1 degree of latitude is 69 miles, 1 degree of longitude is 57 miles. So, and of course, 2 degrees of longitude is 114 miles. So if you go back and look at a map now and say, well, where's EM95? Well, Well, 7,200 seconds longitude and 3,600 seconds latitude, but there's also 69 miles from here to here and 114 miles from here to here. So going that rule again, we went from numbers, now we're going to go to letters, and when we go to letters, we have to divide by 24. So there, EM 95, and there, okay? So we divide the seconds of latitude by 24, we get 150 seconds latitude. Divide 24 into the seconds of longitude, and we get 300 seconds of longitude. Notice these numbers, because we started out as a rectangle, they're always like a ratio of 1 to 2. And I did the same thing with the miles. And by the way, I have a slide, a couple slides at the end that summarizes everything, but I think you can see the pattern. And your kids, if you're following me, these grids, don't do these by hand. You get on Excel and just get a blank Excel page and use those grids and make sure the grids are like a 2-to-1 ratio, and then you could move those into the PowerPoint or move it into your map. So that's what I did here. So this is EM 95. This whole area right here is EM 95, and I put a grid, 24 by 24 grid, on top of that. And I just got an Excel and moved it over, and so now you say, where am I? Well, yeah, I can look through because it's transparent. I can look through and say, oh, that's where I live. So what is it? Well, I go start out since it's alpha, lowercase alpha. Go A, B, C, D, E, F, G, H, I, J, K, L, M. There's M, so I got the M. And then going this way, the row is A, so that's really row A. So what I get out of this is this. I get EM 95 MA. And I showed you before, when I divided, I got 300 seconds longitude and 150 seconds latitude, and the miles I got by dividing 24, so I got 288, 5.75 miles. And now I look at it carefully. This is the development that I live in right here, so I know I'm getting warm, you know, but I'm not done yet. I'm not done yet. You see, if I EM 95 MA, so I have what? Numbers to go through, and then lowercase letters. And then when I get that point, it's pretty close to getting on top of my house. So I'm at EM 95 MA, I got a little bit more to go. Now, what I did now was I put a grid, a 10 by 10 grid, on top of where I think my house is, and I get 7, 3. Now, I always name the column first. So 0, well, everybody gonna make the mistake starting in 1. You want to impress your teacher at school, and say, it says count, start with 0. That's what she says, or he says. Okay, 0, 1, 2, 3, 4, 5, 6, 7. And then the row is 0, 1, 2, 3. So that's how you get 73. So EM 95, MA 73 from that. So now what do you think I'm going to do next? One more time I'm going to break that up, and that's going to be it. So since I'm going to do numbers next, I divide by 10. I divide the miles by 10, and okay. So I get 30 seconds, 15 seconds, and the feet. I changed the miles to feet. All right. So one last thing is the alpha, the lowercase alpha. Okay, and I'm done. So I got EM 95, MA 7. Just did this so I keep track of where I am. So looking at now, I got a grid, 24 by 24 grid, which is 576 areas on EM 95, MA 73 to get the other one. And I didn't mark it, but I go over here all the way to T. If I count, I'm going to get messed up. It is T, okay? Counting this way first, because it's column first, then the row. Go up here, M. So this TM, that's finally zeroed in. And if you want to know what it looks like, there it is. 104 feet this way, 63 feet that way, and 1.2 seconds longitude, and 0.625 seconds of latitude. So we're done. And no one cares it that far, but you should be able to do this and at least get to probably 6 figures. If you get fit, you're doing real good. And this is where I summed up everything, in case you got confused. First of all, this slide shows you everything in seconds of a degree. Started out, and here, it was original 18. We counted over 18 up and 18 down. Went to AA to RR. And then we divide that by 10, went from 00 to 99. Then we divide this top by 24 and got 150, 300. That's AA to XX. Then we divide by 10 for the numbers. We got 15, 30, 00 to 99. Then we divide by 24 again and got 0.625 and 1.25. And so the next slide shows you the miles and feet at 35 degrees latitude. So you could just go through this and then do the same idea over here. The only thing over here is I had the miles and feet rather than degrees. So now, ARL award gives you all kinds of awards. Well, this is a unique award. It's called the Fred Fish Memorial Award because he's a silent key. And he was the first to do this, by the way. So in the United States, there's 488 Maidenhead grid squares with 2 letters and 2 numbers now. Only 2 letters and 2 numbers. They didn't want to make it all the way down to it'd be impossible to get. There's so many of them. If you went more than 2 letters and 2 numbers. So the deal here is, someone said that before. The deal, where did I hear that? The deal is you got to do it on 6 meters. You got to do it on 6 meters. And if you live on the East Coast, working the West Coast on 6 meters may be a little tough. But with FD8 and other digital modes, it might be possible to do that. But here's Fred Fish. He was the first guy that got the award. And poor guy, he must have spent a lot of time on it. But here's something interesting. These are all the people that got the award. And notice that generally by looking at the calls, they appear to be living in the central part of the United States. If you live in the central part of the United States, you can work the East Coast and West Coast on 6 meters. Hopefully you can. It'd be a little bit easier if you're on the East Coast, like in Carolina, and work the West Coast. It'd be pretty hard to do. But anyhow, so notice only 10 people got this award. Only 10. Now, if you look at my WAS award or my DXCC, it's up in the thousands. And today it may be 10,000. It's going to go up in higher and higher. But you have a chance, if you move to St. Louis, there's some guys in our club probably would do it. Move to St. Louis for a year and work the East and West Coast, and you'd be like number 11 in the world. And that'd be bragging rights, number 11 in the world. If you were a tennis player and you were number 11 in the world, that'd be pretty good, But anyhow, so no one else got it. The last one was this year, June 10th, was this guy. Got it last year. I don't know if you could read that, Bill. Guy named Bill. So let me give you some technical information on the data. This the Maidenhead grid system really comes into play in digital modes, really in digital modes, like FT8, FT4, and JT65, and JT9. Again, we're not going to talk about those modes on this presentation. But what I want to pay attention to is this, they require your PC clock to be synchronized with the satellite. Let's skip that, man. So how are you going to do that? Well, there are computer services in the United States. Universities have them. The Naval Observatory in Washington, D.C. has it. But there are universities that have an antenna sticking out the window that receives the satellite time signals. And they put them on the server so you can access through the internet these time signals to synchronize your computer to the satellite time. Now you say, why do this? Well, because when you transmit in these digital modes and receive in the digital modes, you need to be synchronized to the master clock. It makes the transmitting and receiving a lot easier. In the synchronous mode, You don't need like a stop or start bit like in asynchronous modes. So when you study those, you'll see what I mean. So one service is NTP, called servers, and that's a computer program. It's a network time protocol server, and that's the software that I use. And what it is, they'll give you a whole mess of servers that do this operation. So you pick one near you, and they use SNTP protocol, so they don't worry about drop messages or anything. So you have to pick one you like and use it, and you click on it, say sync now, and it'll sync. But one thing is, if you have a Microsoft system, you have to give permission to the system, the Windows system, say, hey, you're not controlling my clock anymore. My clock is being controlled by this atomic clock in the satellite. So, yeah, and this little window comes up, and you just click on it. And just to show you something here interesting, what we have here is the history of the clock before I sync. This is what Microsoft is doing. This is 0 right here, and I don't know if that's 1 second. Yeah, that's a 1 second up there, and this is minus 1 second. So you see how the clock is drifting all the way up there, almost up to 2 seconds. 2 seconds is way too much of an error, and when you're looking at the clock on your PC, you would never know it's off 2 seconds. So when I synchronize it here, I'm synchronizing. You can see I kept pushing the sync button, so you can see I'm oscillating about 0. So the reason why you synchronize, because no need to stop, I already said that. But let's look at the data, then I'll get into why you need the clock. If you want to send an alpha character, all you need is 6 bits. So if you send 2 alpha characters, after the slide's over, you can look at this in a little detail. This is a way of representing alpha characters. So you need 6 bits for one character, 6 bits for another character. For a numeric character, all you need is 4 bits. So the total number of bits here is 20. So that means that to send a Maidenhead grid of the form AA00, you would need only 20 bits. And what I did is I took the Asiatic Russia example out of here, N014, that's N014. So all these bits can be back to back, so to speak. Well, and you might say, well, how can you tell the difference? Well, there's a very complicated code here, demodulation code, to detect the bits here. But the fact that you don't, the idea of stop or start, you don't use that anymore. But they're all synchronous, meaning that you come with a clock, you could decode them very easily. All right. Now, so 20 bits is necessary to locate any place in the world, 2 degrees by 1 degree. So that's pretty neat, I think. Now, let me show you something. I added this today because it happened to me. Suppose you were working, again, I went through the WAS reward that's worked all states, and you needed North Dakota. You know, not too many people in North Dakota. You know, it's cold up there. But North Dakota is in a 7 area code. But you can't assume the call with a 7 code is from North Carolina, because I said before, you can move around a lot and people don't know that. So, I mean, people don't know you moved. But North Dakota has the Maidenhead grids of the following. It covers DN and EN, and these are the numbers. Now, it's the first 2, we're only using DN, it's like DN86, DN87, DN88. These are the numbers that occur in North Dakota. So if I needed, if I needed North Dakota for my WAS certificate, all I had to do is watch for these Maidenhead grids to appear, and then call the ham there, and if he answers me, then I worked him, and I get credit for North Dakota. And if we carry this one step further, you think, well, I'm sitting there looking and waiting for North Dakota to come. I'd rather go out and ride my bicycle and let the computer do the work. But we can listen carefully, though. So all you gotta do is write a short script to look for North Dakota codes, and then make the contact. And with a logbook with FT8 and Logbook of the World, you can make that automatic by writing some script. However, I'm not suggesting you do this because illegal. You have to be near your, your computer to operate. You can't be out riding your bicycle. I suspect some people have done it, but you can't do it. It's illegal. So I'm telling you, don't do it. So I wonder how many hams have done this. I mean, these high school kids, not all high school kids are playing video games. Some are really sharp, and you'd be surprised. So I wouldn't be surprised somebody would do it just for the sake of doing it, not to be malicious or anything like that. So I didn't use this method for what it was. I sat next to my computer and did something. So I was control the computer at all times. All right, I got the information from various sources. QEX is like it's the technical version of the magazine, QST. And I get the Google Earth, and you can look through these. And there is a calculator to do all this. But you could, again, I encourage, especially the kids, to do it by hand with the grids. Your parents may have to help them a little bit with the Excel grid. Well, let me give you a little bit extra here. As a teacher, I always gave my students something a little extra, and basically they hated it because they said, my brain's full, don't give me any more. So just interesting, it would be interesting. Would there ever be a Maidenhead grid of the following? 00000000. According to the rules, it does exist. You wonder, where is it? Well, it turns out it's in Mongolia. In Mongolia, if you look right, Mongolia, the northern part of Mongolia, north of there is the Russian Federation, and the south is China. So somehow you got to get into Mongolia. If you want to go to that spot and operate, your QSL card would have that in it. See, that would be a rare card to get. Yeah, hams always like to be the first to do this and the first to do that. So you'd be the first person to do that. So where exactly is it? I used the computer to find it a little bit, and it's not there. It's somewhere over there. Well, what you'd have to do is calculate where it is, get the GPS rating, location of it. Then when you go to Mongolia, with all your equipment, your tents, your antennas, and all your equipment, generators, go to that area, and then you could send people your card when you get home with this grid on it, and that would be a rare card to get. But you got to remember that you're in Mongolia, and what I read, the people there are friendly people, even though they have Russia up there and China down there. But you've got to remember the heritage of the people there in Mongolia. Ever hear of Genghis Khan? They ride horses and shoot bows and arrows. So when you leave this area, you leave your tent, leave all your equipment, your antennas, your generators, your solar energy cells, and get out. Anyhow, so that's all I got to say is I hope you enjoyed the presentation, and I'll guarantee the next one will be more complicated. And I hope that some kids have done the graphical presentation and found their parents' Maidenhead grid. Thank you. This is Joe Evan Paddle, signing out, 73s. Bye.